There are 7 activities. Activity A, B, C, D, and G. None, right? Activity A, starting point. Sometimes it's not necessary. Starting point is only 1, maybe 2, maybe 3. As long as certain activity doesn't have immediate predecessor, that is starting point. Okay. Anyway, this project has only one starting point, only one, because only A has none, right? So A, starting point, right? 6. And B and C from A, right? B and C. B4, C7, right? And D from C, 2, right? E from B and D. 4. F from D. 3. G from E and F. 7.
Yeah, that's what I got.
Good.
On the A, B, C, did you go directly? You said A, you got A, then you go B to A.
After
See that, okay. I see.
start,
Okay, I see.
see next one and where from. Okay? Using arrow like this. Okay? Then, how many possible passes are there?
3,
3. What are they?
A, B, E, G.
A, B, E, G, right? A, B, E, G. Second one, A, C, D,
E, E,
E,
G.
G.
Yeah.
Third one this way, right?
Yep.
A, C, D, F, G. There are 3 possible passes in this project network, right? Okay?
So why did I think they had to sort of kind of be in a straight line?
Oops.
Because that A, C, D, E, G when I didn't get. A, C, D, E, G.
When you draw network diagram, if you don't use arrow, just line, then confused. Follow arrow. Okay.
Okay.
Here, there are 2 passes, right?
Got you.
So 1, 2, separate.
Okay.
Are you with me?
Yes.
Yes? Okay. Which path is critical path?
The last one,
The last one? How?
25.
25? Let's see. A, B, E, G. 6 plus 4 plus 4 plus 7 equals
21.
21. Second one, 6, 7 plus 7 plus 2 plus 3 plus 7.
Oh, 25.
Is it 25?
Out 24.
It's
Wait.
6 plus 7 plus 2 plus 4, right? For that one.
6,
27,
7, 2, 4.
Four.
Oh,
26.
4. 27,
26.
26 equals 26. The last one, 6 plus 7 plus 2 plus 3 plus 7, right? Equals 25.
Oh, yeah.
So critical path is the second one. This way, right?
Mm-hmm.
So A, C, D, E, G, right?
Yep.
How much select does activity B? Activity B, this one. Let's see. Early start time, 0, 6, right? 6, 10. 6,
13.
13. 13, 15, right? 10 and 15 together, right? Which one you will take?
13.
15.
Oh, yeah.
This one can start after B and D. So this one finish at 10, but this one still work, right? So wait until this one finish, right? So E can start 15 plus 4, 19.
Mm-hmm.
This one doesn't matter, 15 and 18, right? Again, 19 and 18. 19 plus 7, 26. The same, right?
Mm-hmm.
And then backward, 26, 19, 19, 19, right? Minus 3, 16. Minus 4, 15. This one, right? 15 and 16. Which one?
Early.
Only one, 15, 13. This one doesn't matter, 15, right? Just go
Bring critical.
from 1, right? So 15 minus 4,
11.
11, 13, 6, right?
Mm-hmm.
And here 11 and 6,
6.
6, 0. Activity B, 11 minus 6, 15 minus 10. Select B has, select equals for B, 11 minus 6, or 15 minus 10 equals 5, right?
Yeah.
How much select does activity C? 6 minus 6, 13 minus 13, 0, right? So 0 select. Finding early start, early finish, late start, late finish time. Confused, right? Good news. I will not ask about that when you take a quiz and a final. But you need to find the critical path using this method, okay? Adding up. Okay?
We can do that.
Anyway, answer file is on Blackboard. If you need the answer, oops. Okay? answer, look at answer. If you cannot solve, nothing. Right? Any questions so far?
No,
Okay.
sir.
Thank you.
So basically, if you draw it wrong, everything else is gonna be wrong.
Yes.
Okay.
So I say follow my step, okay? Step by step. Don't go fast, okay? Next one, critical path method with 3 activity time is made.
One was enough.
I know this.
Earlier, this class time from 6 to 10:20, certain, right?
Certain.
But you don't know when finish, right? Day by day different. So, like your wife or husband, when you come back home, then, you say time approximately, right?
Estimate, yeah.
So, you expect today 2 chapters, then you expect like 3 hours, okay? Then maybe after 9, right? But if there are 3 or more chapters, then longer, right? Maybe 1 chapter, then shorter, right? So there are 3 activity times. Optimistic time, finish early.
Absolutely.
And then usually like at 9 o'clock we finish usual time, right? And then pessimistic, I give you practice question, then you cannot, it takes long, then longer, pessimistic time, right? There are 3 activity times. Optimistic time, something average time, and pessimistic time. There are 3 activity times. Times are uncertain. This period, time period for this class is certain, but you don't know when finish, right? So there are 3 possible times, uncertain. Then we use this one, and then 3 activity times. Maybe this time, maybe this time, maybe this time. Maybe 30% of the optimistic, 40% of the usual time, something like that, right? So 3 activity times are uncertain and then associated with the probability. So using this method, we can get probability information. I will tell you. Okay, the same activities, designation, immediate predecessor, and then 3 activity times. Earlier one, only 1 single certain time, right? But for this one, there are 3 activity times. Optimistic, most likely, and pessimistic. A, optimistic. M, most likely, kind of average. This one, B, pessimistic. Something like this. A, optimistic time. M, most likely time. B, pessimistic time. Longest time, shortest time, kind of average time. Okay. If we have 3 activity times like this, then find expected time. Expected time using this formula. Expected time equals optimistic time plus 4 times most likely time plus pessimistic time divided by 6 because 1, right?
Because what?
1, 4, 1.
One. Oh, okay.
1, 4, 1,
6, right.
6, right? Did you take statistics?
Mm-hmm.
I will test you. Do you know weighted time, weighted average?
Mm-hmm.
Usual general average, each member's role is the same, right? If there are 4 numbers,
Yes.
and then average, then divided by 4, right? But the same as first one times 0.25, 0.25, 0.25, 0.25, because their role are the same, right? Even.
Right.
But if their role are different, that is weighted average, right? This one is a weighted average. Optimistic time coefficient is only 1. Most likely time, more often, so give higher coefficient or weight. 4, pessimistic time, only 1. So 1 plus 4 plus 1 equals 6, divided by 6. So this expected time is weighted average. And then always using this formula. So this one, I need more space. Expected time for activity A equals
Ten. Yes.
10 plus 4 times
4 times
22.
22. Plus 28.
plus pessimistic time is 28, right? Divided by 6 equals, using your calculator, then it will be 21,
21.
right? If I need expected time for activity B equals, optimistic time for activity B is 3 plus 4 times 4, right? Plus 5 divided by 6 equals 4. Good? Using the formula, we can get expected time for each activity like this. Then it's the same as single estimation, right? Right?
Say so.
We have only one activity time, right? After we get expected time. Then we can draw network diagram using expected time, right? Mm-hmm.
Oh, you're saying now that we have the expected time, we can use that. in our-
There are three activity times, right? Optimistic, most likely, pessimistic. Using three activity times, using a formula we can get
Estimate,
expected time.
expected time, yeah.
Then that is the same as single activity time, right? Using single activity time, we can draw network diagram like this, and then the same process. Draw, find how many possible passes. There are three. Among them, longest is critical path, right? For taking test, you don't have to find early start, early finish, or late start, late finish. You don't have to find. Just adding up activity times for each pass, longest is critical path. In this network, A, C, F, G is longest and critical path. Duration, project time is 38. Okay? Too fast? Are you with me?
Yes.
Yes? Let's see. Let's see.
Oh,
So
God.
critical path is A, C, F, G, and project time duration is 38. So follow steps when we did, right? Draw a network, possible passes, adding up, find critical path, and project time. You did, right? You didn't? Okay or not?
Yes.
Can I go next? Okay. This 38 is not certain time because they are expected time, kind of expected project time, right? It may be 37, maybe 38, maybe 39, maybe because we use three activity times and then expected time, right?
Yeah.
Question. The project time, expected project time, finish time is 38, but this is not certain, something expected time, so we can ask something like this. The probability of completing the project in 35 weeks. 35 weeks. If this one follow normal distribution, you took statistics, right? So you know what is a normal distribution.
Eagle in head. Yeah.
Good. Bell shape, right?
Yeah. that's-
Symmetry. Looks like this.
Right, but why?
Normal
you saying
distribution
35?
looks like this, right? Left and right from mean the same size, right?
Mhm.
And then this one is mu,
Yeah.
average mean, right?
Mhm.
Okay, 38 duration. We used expected time and then find this 38, right?
Yeah.
This is kind of mean, weighted average, right?
Yeah, kinda.
So 38 here. Then this one ask you in 35 this area. This one ask you find this area in less than 35.
Oh, okay. Mm-hmm.
So this class operations management's prerequisite is statistics. You need something knowledge about statistics. Okay. To find that area, we need z-score, z-value, statistics. In statistics, maybe this one different formula for this one. D minus T E, the desired completion time, that is asking time, 35, minus TE.
Wait. I'm
Okay.
sorry, go back. What'd you say was asking time? D.
D.
Got it.
Question ask you, right? 35.
Yeah.
So, desired completion time is D is 35, asking time. TE is expected completion time, project duration, 38, right?
Right, okay.
38. And then square root. This one, sum of, what is this?
Standard deviation.
Standard deviation, square,
Oh, y'all knew
square
that.
is variance, right? This one is standard deviation, square is variance.
Oh, here we go.
CP, critical path. Sum of the variance along the critical path, We need variance. Variance equals B minus A. B, what is B? Pessimistic time. A is optimistic time. Divide by 6 and square. Okay. Go back to the chart. Variance for A activity A equals B minus A. B is 28, A is 10. Divide by 6 squared. Equals 18 over 6 square equals 3 square equals 9. 9, right? Okay? How about B? B minus 5 minus A is 3. 5 minus 3 divided by 6 squared. 2 over 6 squared equals 1 over 3 squared equals 0.3333 squared equals 0.1111. Right?
Correct.
Okay? So using this formula, B minus A divided by 6 squared, you can get variance for each activity, 9.11, 2.78, and so on. D is 35 minus 38 divided by sum of variance on critical path only. Not sum of all. Only on critical path. Only on critical path. Critical path of this project is A, C, F, G, right? So add up 9 plus 2.78 plus 0.11 plus 0. Only on critical path. Don't add all of them. Variance, sum of variance on critical path. Not all of them. Critical path is A, C, F, G. So add up 9, 2.78, 0.11, 0. Got it? So 35 minus 38 is negative 3. 9 plus 2.78 plus 0.11 plus 0 is 11.89. Square root is 3.45 equals negative 0.869. Round of negative 0.87. Okay? Good? This negative 0.87 is not percentage. This is z-score, right? Using that z-score, we can find area. normal distribution chart is attached. Where is negative 0.787? We cannot find, right?
No.
Mm-mm.
We can find between, right?
Mm-hmm. 85 and 90.
Between, right? If it's between, take closer one. 0.9, 0.85. Which one is closer to 0.87?
9.
0.9? Are you sure?
25 is only 2, 0.9 would be 3. Closer to 25.
Between 0.85 and 9. Oops, need more space. One, two, three. 1, 2. This one is closer, right?
Mm-hmm. Yeah.
So take this one.
Mm-hmm.
Negative 0.87 is closer to 0.85, right? Mm-hmm.
Correct.
So take that one, then it is 0.19766. 0.19766.
Wait a minute.
0.19766, right?
Oh.
I will draw this one again. $38 here, right? And question asks you in 35, right? This area, right?
Mm-hmm.
This one, 19.766%. Normal distribution and standard deviation. Z-score. From mean, left side is negative, right? Right side is positive, right? So this one was point negative. Z-score was negative 0.87, right?
Mm-hmm.
But we take 0.85, right?
Mm-hmm.
Got it?
Got it.
Okay.
More about statistics.
Why are you laughing?
I was just laughing because I took statistics just this last term, and our statistics instructor was terrible. And I'm gonna, to put it mildly, she was terrible.
Not me.
I just learned more about statistics in 5 minutes than I learned in 9 weeks. But I thought myself.
Okay, next question. Next question.
Oh, Lord. Okay,
I can do it.
I think I got it. Let's do it.
Again, normal distribution. 38 here.
It's now 40.
This one asks more than 40. 40 here and this area.
Okay.
We need z-score for 40. D minus T, the same one. D is desired time, so asking time, right? Asking time, 40.
40.
Minus 38, and then the same. Variance on critical path. 9 plus 2.78 plus 0.11 plus 0 is 11.87 square root. 40 minus 38 is 2 divided by 3.45, right? Then 0.58. 0.58. Then find z-score 0.58 on the chart. 0.58 we cannot find, but between, right? Between 0.55 and 0.6. Which one is closer? 0.6. So take 0.72575, right? Just a moment. So draw again. $38 here and 40, and this area, right? And the area associated with the z-score 0.58, that is 0.72575. What do you think? This is 72.575%. Too much. Too much, right? This is 0.5, right? But this one should be smaller than 0.5, right? But given area is 0.72575, 72.575, too much, right? Because the chart I will bring up the okay. Look at this. Given area is from certain z-score left side. This chart. You know what I mean? From a certain z-score left side.
Right. So you gotta subtract 100.
So this one, 0.72575 is from certain z-score left side, right? So if we need the right side from the certain point, total area is 1 minus this one, right? So answer is
0.27425.
one minus 0.72575 equals 0.27425, 27.425%. Okay, question. Ask you in or less than. That means left side, right? Using that given area. If question asks you like this, more than, longer than, then right side, right? If it's right side, you should subtract from 1. Because the chart gives you only left side. Do you know what I mean? Okay.
Can you go back up for one? Go back up a slide, please.
Which one?
The one with the breakdown of that formula you just did, right there.
Okay. Good.
Yes, thank you.
Time cost model or PERT. Our textbook include, but I will not cover this part. But just to let you know, not in your lecture note, because I don't cover, but I just show you something. If we have critical path method, and even a single or 3 activity times estimation, time information only, then we can draw and then we can find the duration, the